Let's do some problems with logarithms. So here you have to transform a certain product of three things into logarithms. So you go log 2 plus, because products are turned into sums, log of x to the fifth plus log of y cubed square root, which is actually a power of 1/2. So log 2 is just log 2. The second one, we can bring this exponent inside the log, outside the log, so it's 5 log x. And this one is really y raised to the power of 3/2, because these two exponents multiply each other. And therefore, the exponent 3/2 comes out, and what's left is the base, which is y. The next one, oops, it's not plus, this one is 3/2 times log y. And that's the final answer. The next one is a quotient of two things. So log turns quotients into differences. So we have log of 10x to the fifth minus log of cube root of y. And then this is a product, so this is log of 10 plus log of x to the fifth. And then minus, this is log of y raised to 1/3, because cube root is exponent of 1/3. So now log 10 is 1, because you have base 10. Log without any number in the base means log base 10. So log base a of a is always 1, because it's the exponent you raise a to get this thing that's inside the logarithm. So log base a of a is 1, and therefore this is 1, plus I take the exponent 5 and bring it outside the logarithm, so this is 5 times log x. And the same thing for the last term, which is 1/3 log y. Next question, we have again a product and a quotient, so I can write it as log 10 over x plus log of 3 raised to 2x. This is difference of two logs, so log of 10 minus log of x. And this one, I can bring the exponent outside the log, so the exponent is 2x. So 2x times log of what's left inside is 3. So this is going to be log of 10 is 1 minus log x, and the last term is 2 log 3 times x. By convention, we write the constant in front of x's. Okay, next question is asking the opposite. So you want to bring all the exponents inside the log. So we'll bring this 2 inside the log and we'll put it in the exponent. So this is log of x squared minus log of 2 minus x to the third power. And then the difference of logs becomes a quotient inside the logarithm. So this is x squared divided by 2 minus x, the whole thing cubed. Same thing here for this one. You bring this 1/2 inside the log. So this is log x to the 1/2, then minus a log of 2 minus x raised to 2/3. So this is log of square root of x minus log of cube root 2 minus x squared, and therefore log of square root of x divided by cube root of 2 minus x, the whole thing squared. Okay, next up are some equations. So for this is exponential equals to a constant, so you take ln. So ln of 10 to the x equals ln of the right hand side, and here you apply the property of logarithms. The exponent comes out, so x times ln 10 equals ln 3, and therefore x is equal to ln 3 divided by ln 10, which is also equal to log of 3, because it's log base 10 of 3. For the next one, you proceed the same way. So you take ln, you get ln of 10x squared equals ln of 3, x squared times ln of 10 equals ln of 3, x squared equals ln of 3 divided by ln of 10. Now you plug this in the calculator, for example, or you solve this. So this is x is equal to plus or minus square root of ln 3 over ln 10. For the next question, you need to solve for 10 to the x first. So you bring this one over to the other side. So you say 2 to the 10 to the x equals 3 minus 1, which is 2. Then you divide by 2. So you get 10 to the x equals 1. And then you take ln or log. Let's say take log. So log of 10 to the x equals log of 1. And therefore, because log and 10 to the x are inverse functions, we get x equals log of 1, which is 0. Actually, log base any number of 1 is 0. So here we get 0. We couldn't take, no, so note, can't take log as it is. Can't take ln right away. We have to solve for 10 to the x first. Because if you took ln of the left hand side as it stands, you would have ln of a sum, and there's no way to simplify that. Okay, next question is ln x cubed equals 3. So what we do is we raise this to the power of e. So we apply the function e to the x to left hand side and to the right hand side. E and ln cancel, and we have x cubed equals e cubed, and therefore taking the cube root, we get x equals cube root of e to the 3, and we get this is e. For the next problem, you have to write the left hand side as a single ln. You cannot apply the function e to the x as it stands. Maybe you could, but okay, so you combine ln's into one. This is a difference of two things. So it's ln of a quotient. So ln x minus x over x minus 2 equals 1. And then we take e to the ln of the same thing equals e to the 1. E and ln go away, so we have x over x minus 2 equals e, and we have to solve this for x. Now it's something that has denominators. We multiply by the denominator, and therefore I get x equals e that multiplies x minus 2. So x equals ex minus 2e. Then we bring all x's, all unknowns to one side. So I have x minus ex equals to what's left. And I collect all the coefficients of x. So it's 1 minus e times x equals negative 2e. And therefore x equals negative 2e divided by 1 minus e. And that's my final answer for this problem. And the last problem says this. So you solve for ln first. Solve for ln x first. And notice ln x minus 1, that means this minus 1 is not inside the ln x. So this is ln x. So this is not ln of x minus 1 like this. Okay, so you first have to solve for ln. So you bring this over to the other side and you get 2 ln x equals 5 plus 1, which is 6.